In this video, I'm going to show you how to create a surface of an existing pond. So the first thing we're going to do is we're going to bring in our survey. So I'm going to need to set my coordinate system to match the coordinate system of my survey. And I use that using the Edit Drawing Settings command. I'm going to drop down this zone and I'm going to go to USA, New Mexico, and then drop down the coordinate systems, and I'm going to choose NAD 83 East Zone US Foot because that is the coordinate system I did my survey in. If you were somewhere else in the state, you would select the appropriate coordinate system for where you did your survey. I'm going to hit apply and OK. Next thing I'm going to do is bring in my survey points. So I'm going to go to Insert, Points from File. I'm going to go find my survey. I'm going to select it and hit Open. On the point file format, I'm going to scroll all the way down and select PNEZD. Right now, I'm going to add my points to a point group because that will save me one step later on. So I'm going to check the box. I'm going to add or create a new group, and I'm going to name this Pond Surface. Since this specific survey only has the pond survey points in it. So I will click OK and OK. If you get any kind of pop-up like this, you can just hit OK. So once the points have been inserted, I'm going to use the command ZE for zoom extents, hit enter, and it's going to zoom to all my points. So these are my pond points here. Since I set a coordinate system before I brought my points in, I can actually turn a map on just to make sure we're in the right spot. So I'm going to go up to this top toolbar and hit Geolocation, and I'm going to turn an aerial map on behind my points. I usually use this as a quick check just to make sure everything with the survey turned out right. And you'll see this is the pond on the aerial, and this is where all my shots are. So everything looks good. Now, just for now, I'm going to turn my map back off because it makes things a little easier to work with. I'm also going to change the scale so that it's easier to differentiate my survey points. So what we did when we did the survey, actually I'll turn this map back on, is when you're taking a topographic survey of a pond is you want to capture the very top of the pond. So you'll see we have points called top pond, and we're going to go all the way around the border of this pond. Then we're going to get some in the middle, so this is usually about halfway down the slope. In this one they're labeled mid-pond, and so we do that all the way around the pond again, and then we capture the bottom of the pond. Usually you'll want to get the bottom of the pond around the perimeter, and then maybe a few shots in the middle, especially if there's a little bit of variation in the bottom of that pond. So those are the points that are really important to capture in order to do any of this in AutoCAD. So the first thing we're going to do is we're going to create a few polylines to differentiate the different parts of the pond. What I usually use for these, since we're going to be creating a 3D surface, is I actually use a 3D polyline. So the first thing I'm going to do is I'm going to do a 3D polyline of the top of my pond. So the command for that is 3D poly. Hit enter, and everything should be like drawing a normal polyline. What a 3D polyline is instead of creating this line, you know, at elevation 0 or whatever, because it's an arbitrary line, it's actually creating this three-dimensional line connecting the elevations of each of these points instead of just the X and Y direction. So I'm going to start in one corner, and I'm going to get all of my top pond shots all the way around the pond. So now that I'm done, just to be sure that I've closed that 3D poly, I'm going to type C for close and hit enter. So the next thing I'm going to do is I'm actually going to get a length on this, because with pond liners, the pond liner doesn't end just at the top of the pond. In fact, you can draw it in here with a regular polyline. If we go over here, usually a pond liner, you have your bottom of your pond here, and then you have your slope that comes up. But then once you have your slope, you actually end up coming across 2 feet, and then you're going to trench down 1 foot by 1 foot, and then trench back up. So what this does is, all of this is earth. This is the inside of your pond. This pond liner is going to come up the side of the pond, go over 2 feet, come down 1 foot, over 1 foot, and back up 1 foot. This is going to be filled in with dirt on top, and that keeps the pond liner from slipping out of here. So if a wind gust gets up on here, or really anything, it's going to be trenched in right here. So what we need to do is we need to add this length, which is 5 feet, to the entire perimeter of this pond. So there's a few ways you can do this. You can actually take these points and extend them out 5 feet, have them be the exact same elevation, and create all of those points. I find it easier to just select this perimeter line that I just drew. I'm going to go to my properties, and it gives me a length of 997 feet. So I'm going to estimate 1,000 just to be easy. So 1,000 feet, and I'm going to make note of that. So I'm going to pull up my notes, and I'm going to say perimeter equals 1,000 feet. And that's actually going to get multiplied by 5 when we do our area. So it's going to be times 5 feet equals 5,000 square feet. So that will actually end up being added to the total square footage of pond liner that we need. So we just need to remember that for the end. Alright, so the next 3D polyline that I'm going to differentiate is actually the bottom. And it's not going to include all of the bottom shots, it's going to be the perimeter of the bottom. So these couple shots that are in the middle of the bottom, we will leave them as is. So what this does is this, when we create the surface, this gets used to basically differentiate where the side turns into the supposed flat bottom, and it kind of keeps the different areas from creating that tin surface from each other. It'll make more sense later. So right now we're just gonna do the work now to create the 3D poly, and I'll show you how to use it later. So we're gonna type that 3D poly again, and I'm gonna start here in the corner just because it's easy, and I'm gonna capture these bordered bottom shots. Again, we're going to make sure to close it by typing C and enter. So now you'll see this is the top of our pond and the bottom of our pond. Looks more like a pond. So the next thing we're going to do is we're going to create a surface. So in our drawing, you'll see surfaces right here. We're going to, well, if you hit the plus, it'll expand out all of your surfaces. So what I'm going to do actually is I'm going to click on the word surfaces and I'm going to right click and I'm going to create surface. So the first thing we're going to create is our pond surface. Style, I like to just leave it at contours 1 and 5 and triangles. So it's going to show me 1 foot and 5 foot contours, and it's going to show the triangles where that tin surface is creating its elevations from. And I'm going to hit OK. So now it created a surface, but we haven't told it how to define that surface yet. So we're going to hit the plus mark. Then next to definition, you can expand definition. It's back. And then point groups. Now you remember when we brought our survey points in, we already created a point group with all of these points in it. If we had other survey points in this survey, which originally for this survey we had a pipeline coming in and some other stuff here. For the purposes of this video, I took all of those points out. But normally, you might have to create a point group with just your pond points in it, or manually select which points go into it. So right now, I'm going to right-click on point groups, and I'm going to hit Add. And I'm going to select that pond surface point group, since it already has all of our pond points in it. And I'm going to hit Apply and OK. So now it just created the surface. But you'll notice it has some contours kind of jetting out right here and some contours jetting out right here. And I know from the survey that that's not really how it looks. That's why we defined this bottom. So we're going to put a break line. And that's why we created this 3D poly at the bottom, is we're going to use that as a break line. So we're going to right click on break line and hit add. The description is going to be pond bottom. Will be standard, and we will hit OK. So now it wants me to select objects. So this 3D poly is going to be my break line. And I'll hit enter. And you'll see it regenerated. And now the bottom of this is mostly flat with a little bit of contours because we took some other shots in the middle of the bottom. So now we actually have our 3D surface. If you want to view the surface, if this is a little too many lines for you, you can actually click on the surface, just left click on it, and then right click and go to Object Viewer. And this will actually show you your 3D model of the surface you just built. I find it easiest to see it in shades of gray, but you can play around with whatever works for you. Shades of gray to me is just the easiest to see. So it comes in just looking at the top. So I'm actually going to pick a corner and I'm going to left click and rotate. And I'm going to rotate this pond surface. So I can pick different areas, and now you can see it take that 3D shape. So now you can see this pond. And so now you can really see why we drew that 3D polyline right here around this bottom. And why you don't want to use a regular polyline is because a regular polyline doesn't have an elevation assigned to it, whereas a 3D polyline is going to match the elevation of each point that you're selecting when you're creating that polyline. So this is your 3D pond. So you just created basically an existing pond. You surveyed this top area, the middle, and the bottom, and you recreated it in a 3D model in AutoCAD. So now what we're going to use this for is we're going to have AutoCAD do all the work for us on figuring out the square footage of pond liner we need. So to figure out the pond liner, basically the pond liner needs to cover all of the surface area of this pond, plus that extra 5 feet we already calculated around the outside. So this is actually quite easy. So we're going to go back to our model space, and on our pond surface, we're going to go and left click, just select pond surface, right click, and go to surface properties. Then you'll go to the statistics tab, extended, and your 3D surface area is right here. So 3D surface area means it's the surface area of this pond going all the way down the sides, across the bottom, and back up the other side. And it does the entire thing. So for this one, it's 51,573, we could say. So if we have 51,573, and just have a calculator going, and we're going to add on the little bit of pond liner that needs to go around the edge. So if we bring that back up in our notes, this is going to be an extra 5,000. And remember then units, just double check. The units should be at this point in feet squared, square feet. So if we add those two together, 51,573 plus 5,000, we have a total of 56,573 square feet of pond liner. You can do the conversions. I think this one might be contracted in square yards, but it's a really easy conversion. But now you have a base point, 56,573 square feet. Usually on these, I like to add a little extra as well, either 5 or 10% when we're into contracting, because this hasn't yet taken into account the overlap where they seal different widths of liner together, as well as, you know, any small undulations on the land, user error, getting a little bit of air trapped underneath it, anything like that. So I like to increase this by anywhere from 5 to 10% when we're going to write that contract. Just letting the producer know this is close to what it should be, but they're actually going to need to order more than that to make sure they cover everything. So the other thing we can do now that we actually already have the surface is we can actually find the volume of this pond. So in this case, the producer wants to expand the size of the pond for their pivots, but we need to see if there's a resource concern for that. You know, is the pond big enough as it is? So I've calculated how much water his pivots use, and then I need to see if this pond is big enough to provide that amount of water to those pivots. So I need to go get the volume of it. So the way we do this is we're actually going to create a second surface. So we have the surface of the pond itself. We're going to create a second surface that just goes over the top. Think of it like a lid for your pond. And that's why we created this other 3D polyline that comes around the top of the pond. So we're going to go over here to surfaces again. We're going to right click. We're going to create another surface. And this one is going to be top of pond. I'm going to turn this style to off just because it's pretty much flat and we don't need to see it. It would just be too much going on. So I always set it to off. And we hit OK. So now we need to go define this top of pond. Now since we created a 3D polyline, we don't need to define it by these individual points. We can just define the break line of that 3D poly. So we're going to select break line, right click and add, and we're going to label this top of pond and hit OK. Now it wants me to go select it, so I'm going to select 1 second. It is trying to select the surface right now and not select that 3D polyline that's hidden underneath here. So I'm going to turn this surface off for a second. Surface properties, information, and we're going to turn that to off, just so I can find that 3D polyline. We didn't delete the surface, we just turned off all those contour lines. Alright, so now we're going to go back to our top of pond, definition, break lines. We'll right click and add. This is, you can name it. And then OK, and now we're going to select that 3D polyline. You should see down here selected objects 1 found, whereas earlier it was saying 0 found because it was trying to select the pond surface. So once we have that selected, we hit OK, or hit enter. So now it has created this top of pond surface. We can't see it because we have the break lines or everything turned off right now. If we wanted to see it, we can go into surface properties, under surface style, and we can change it to contours. And now we can see it coming straight across there. But I'm going to turn it back to off because it just clutters things up. And I'm going to turn my pond surface back on because I like to see it. So I can show you a different one. We can do 2 and 10, just so you get a little different look. So now you'll see it's 2-foot and 10-foot contours. It looks a little different than the 1 and 5, but it still has these triangles, so that's showing you where your tin surface is coming from. So the next thing we're going to do is we're going to create a volume surface. So under surfaces, we're going to right click and we're going to create another surface. But instead of leaving it as a tin surface, we're going to create a tin volume surface. So what this does is it takes 2 existing tin surfaces and figures out the volume difference between the 2 surfaces. So under name, this is going to be my pond volume. I'm again going to turn off the contours. My base surface is going to be the actual pond itself, so pond surface. And my comparison is going to be that top of pond surface, which is basically my lid to my pond. For this, we can use 1 and 1 because we aren't actually excavating this pond. If you were doing this to excavate a new pond, you would have to use a 1.25 cut and fill factor. But since we're just evaluating an existing pond, you leave this as 1. Now we're going to hit OK. Right now it's giving me a little bit of a little orange triangle here. Usually when I get those, I like to right click and rebuild the surface. Oh, never mind. I'm wrong. So it's when you hit the triangle that the surface is out of date. That's when you need to rebuild the surface. So we're going to go do that for this volume one. Since I changed something, now the volume's telling me something's out of date. Rebuild the surface. So in volume, I'm going to right click and I'm going to rebuild. So now this pond volume is a volume surface comparing this original pond and our lid, the top of the pond. So now I can right click and go to surface properties, statistics, and volume, and this net volume down at the bottom is the volume of our existing pond. So I can let this producer know that his pond can hold 10,437.36 cubic yards of water. And that is in its existing situation. If he were to expand it, of course, it would hold more. If it were to have more sediment deposition later on, then it will hold less. So in this case, I had calculated that his two pivots, each running for 18 hours, would use approximately 9,000 cubic yards of water. So since his pond can hold well over 9,000 cubic yards of water, there is not a resource concern that I can find as the engineer to make his pond bigger. He will probably still want to make his pond larger on his own, but his pond will meet the resource concern of providing water to those pivots. So if you wanted to do this, you could screenshot it. That's usually how I get these volumes. I screenshot it and kind of include it with my drawing. Same with the square footage surface area for the pond liner. So now you know, basically this is how you survey an existing pond to figure out the surface area for pond liner and also to figure out the volume of water that that pond holds. If you have any questions, please reach out and let us know. Thank you.